All right, yeah, I just want a question answered. You ain't answered it yet. I want in feet. How much curvature is in 120 miles?
Okay, so in 120 miles,
Yeah.
there's 1.7 degrees, which is 120 miles. So
In feet, you know,
yes,
my
yeah,
measuring
so
tape don't go by degrees now. In feet, we're going to do this down to feet or meters, whatever you want. So I got Earth curvature calculator open. We're going to do this right here. We're going to do this right here. Share screen. Since I can't get an answer, and I always get deflections, we're going to check the work. We're going to
okay,
check the work. All right. Now I want it in feet. You're deflecting to
okay,
degrees. Now, 120 miles. Now, what is the curvature of the Earth in 120 miles? I want you to answer
it,
this.
okay. So it's whatever 120 miles is in feet.
All right, let's do the miles. How do we do the math? What is it? 8 inches times mile squared. Okay, let's start there. You admitted to
No,
that.
no.
Yes, yes. That's what you admit. I took a picture of that comment in case it's deleted. You said
Yeah,
8 inches times mile squared is
that's
correct.
for
But
drop, not curvature.
no, do what?
So drop, as I explained, was from the tangent. So basically, if your eye was halfway into the ground, then eight
No,
inches per
no.
mile.
You're deflecting. No, ma'am. No, ma'am. We're not going to start deflecting. I'm going to keep you on
I'm not
subject.
deflecting. I'm
No,
answering the question.
ma'am. I asked the plain question.
Yeah,
And we're going to use the Earth curvature calculator in miles. Now, you're deflecting to something that's
I'm not.
not an
I'm not
answer.
deflecting.
Okay. Now, I want you to sit back and watch your screen since you're refusing to answer. Okay, I was 2,500 foot up. You mentioned height of the observer. Now you're not even touching that. I took a picture of that comment.
Yeah.
Distance to the receive, distance to the object, 61 miles to the horizon. Now, first 61 miles to the horizon, that means there's 120 more miles, roughly. Now, obscured object park. Now, if that mountain is less than 2,000 foot, I shouldn't have seen that mountain at all, but yet I did.
Okay, so
Now,
what I'm trying to say is that 8 inches per mile squared is from if your eye was at the surface. So if your eye was
that's right.
literally in. Yeah, hold on.
And here's the
Can I
2,500
explain to
foot.
you?
My elevation was 2,500 foot. I'm rebutting your rebuttal before you ever rebut it.
I haven't
You talk
even
about the eye
explained
level
for
of
you
the
to
ground.
rebut. I haven't even explained what I'm trying to say for you to rebut. Can I
I know
explain
what you're going to
first?
say. You just said it's at the observer's eye level. Now I'm
No,
sitting here
no,
showing you. Yes, you just said that. I'm sitting here
no.
showing you my eye level is at 2,500 foot up.
Yes, the 8 inches per mile squared does not include the eye height. What I'm trying to say
That's
to
the
you,
ground level. That's the ground level.
see,
That's at my
you're not letting me explain though.
height.
That's the thing.
You don't have to. I know what you're saying.
Okay, so what am I saying?
At the ground. That's at the ground under my feet, right?
Okay,
That's
so
what it is.
if you're using 8 inches per mile squared at the ground and you're at like 2,000 feet or whatever you said you are, then it doesn't apply, does it?
Your reading comprehension is pitiful. Now you said 8 inches.
Again, attacking me rather than addressing the point. The 8 inches.
Ma'am. Don't make me mute you just so I can get this out.
I'm
I'm
not.
going to repeat your words. I'm going to repeat your words. 8 inches times mile squared is at ground level. That means under my feet. Now, what
Yeah.
is the curvature rate? Now, if I go up 2,500 foot, we just got to knock 2,500 foot off the number we get. Now, let's go look at this is complicated. Let's go to an easy one. Here we go. This is a good one. This makes it simple. Now, you're deflecting.
I'm not deflecting.
My eye height
No.
is 2,500. All right.
Am I gonna be allowed to speak, or?
I'm trying to correct your deflection right here because you're deflecting.
No, you're not. You're not allowing me to speak. Every time I try to speak, you talk over me. So let me know when it's my turn to have.
I was just correcting you on what you said. Now
you're not correcting me when I've got.
Yes, ma'am. You said it is at observer's at the ground level? And I said, yes. And I asked you if that was under my feet. And you kept saying, it's at the ground level. I said, yes. And so everything has already been clarified. You do not have to clarify nothing else. I agree. 8 inches times mile squared, as you would admit, is under my foot. That's at ground level. I agree. So why are you sitting here trying to explain? I agree with that.
Because you're not understanding what I'm trying to say. This is why I'm trying to explain. But see,
my
see,
eye,
look,
my eye is on the ground. You're telling me I don't understand, but I'm telling you exactly what you're telling me. That 8 inches times mile squared, does that mean laying my head on the ground level, not on top of the mountain, on the ground level? I know what you're talking about.
Yes, but every time I'm trying to explain, you interrupt.
I know what you're talking about, so you're wasting breath.
Okay, so can I just explain what I'm trying to explain first? Let's say you do understand. Can I just get my point out first?
I understand. Don't say if. I understand. I understand.
Can I get the point across so that we are on the same level, so that I know that you understand? Yeah.
Hold on. Speak.
Okay. So what I'm trying to say is that 8 inches per mile squared is if your eye was literally on the ground at the surface level, so not the observer height, literally if you was at sea level on the ground, your eye is literally in the water half and half. And then 8 inches per mile squared applies, but only to the horizontal, so from the tangent. And then it's the drop, not the obscured height. So it doesn't tell you, hold on. So it doesn't tell you how much of the object, let's say a mountain you're looking at, it doesn't tell you how much of that mountain would be hidden.
Yes, it does.
Do we understand?
You're wrong. Yes, I understand you're wrong because my eye is at ground level.
Why am I wrong?
That's what you just said. Your eye is at ground level. Half in the water and half out. That means you're looking out and you're seeing the ground. Straight out from my eyes. Here's the ground. Do you understand what I'm saying?
Okay, so your eye, so literally.
Can I get out what I'm trying to explain?
Yep, carry on.
Now, here's my eyes. Here's the ground. Here's the water. 8 inches times a mile squared. What's so hard to understand about that? I understand that. Now, when it curves so far, do you know how much do you know how a sphere works? If you got so much curvature in a mile, you'll have that much more curvature in 2 miles. That much more curvature, and it don't make a straight line down like y'all claim. If you got an arc, okay, you just add that arc to that arc to them other 2 arcs, and it makes a circle. How much in 120 miles does the Earth curve? It's a simple question.
And it curves 1.7 degrees, which would be 100. Right there, let me finish. Which would be 120 miles.
What?
See, this is the thing. You're not understanding that the curvature rate.
You're trying to explain something totally ridiculous.
No, the thing is, we have a sphere, right? The globe claims a sphere of 24,901 miles, right?
24 a sphere? No, it claims about 4,000 miles around.
No, the Earth, the globe Earth, is 24,901 miles.
Well, I read it was 39,000. So
no, if you Google, you can Google it right now. The circumference of the Earth is 24,901 miles.
I wonder if I still got that open on my phone too. Or maybe my eyes. See, that's why I don't like typing. But it don't matter because if you got an arc, you're still not telling me the curvature of the Earth. You're avoiding that answer. You're saying
I am telling you
120 miles. The distance is 120 miles from my eyesight.
And now, I'm telling you the 69 miles. I'm telling you the 69 miles per 1 degree. So if you're saying you're looking at something 120 miles away, then obviously it's 1.7 degrees, which
that's where you're deflecting. You're not going with miles. You're trying to deflect because see now y'all going y'all was using we're up this angle. That's because we can see. Now you've gone to degree. What happened to the angle you was up? You're talking about a degree. Now you're talking like I just dipped my eyes down and I can look
Because-
straight. No.
Because you didn't let me finish. I was going to say 69.
You're not
I was
look,
going to say I was going to answer in miles. I was going to say
okay,
1 degree
Yeah,
is
okay.
69.
you won't answer.
I was
Go ahead and talk. I'm gonna prove you wrong. Where's the camera? Keep talking. Keep talking.
that 1
Keep
degree
talking.
is 69. I am trying to. So I'm trying to say that 1 degree is 69 miles. Therefore, 120 miles is 1.7 degrees. So in 120 miles is 1.7 degrees. So you're asking how much it curves over 120 miles is 120 miles amount of curvature. The thing is, the curvature is not the hidden amount. The curvature is not the drop rate. The curvature is not 8 inches per mile squared. It's not the amount
That's what.
hidden.
Okay. Now. You just said curvature is not 8 inches times a mile squared, but yet
Correct.
you admitted curvature is 8 inches times a mile squared.
No,
How
that's
come
the
you're-
drop. Drop is
Okay,
not
now,
curve.
Hold on. I'm gonna answer the question you refuse. 120 times 120 miles squared times 8 inches, 115,200 inches. Divide that by 12, that's 9,600 foot. Now that means from where the mountain sits, there's 9,600 foot of curvature. Now I'm up 2,500 foot. Do you understand what subtraction is? 9,600 subtract 2,500. Can you do that? Subtract 2,500. 7,100 foot. I shouldn't have seen that mountain, lady. There's the answer you refuse. You know why? Because it proves everything you say is a lie.
The thing is, by using 8 inches,
let's hear
see,
about
you're
this.
not letting me answer.
Now let's hear about your little deflections.
No, it's no deflection.
That means nothing because you just got proved. You
No,
admit 8 inches
no.
miles is correct. Then you talk about the observer's height. eye
Yeah,
height,
because
yes.
yeah,
And then the distance. Yes, we've done that on the Earth curvature math, and it come up. You're wrong.
no, because you haven't
What about that?
added. The thing is, with 8 inches per mile squared, as you just did, it doesn't include the observer height. Like I said, your eye literally
I
has
just
to
did
be.
that. I was look. I was up 2,500 foot. My gosh, are you that ignorant? Let's go.
No,
look at the
there's a
video. I'll show
difference
you the
between.
math. I'll
There's
show
a
you the
difference.
math. Look, you said it didn't include the observer's height, but yet here's 120 miles. 120 miles. Where's the phone? For you, right there. 120 miles times 120 miles times 8 equals 115,200 inches divided by 12, which makes it feet. That's 9,600 foot. I was up. Now the observer's eye height, there I am. I was up 2,500
Again,
foot. I
yeah.
allowed for it. Now there's 7,100 foot. That mountain is not 10,000
Again,
foot tall. I saw about the whole mountain.
Again,
Now,
even if you did see the whole mountain, you're doing 8 inches per mile squared, which is only drop. So let's imagine this. You've got a car.
Do you
Hold
understand
on.
what a ball? Do you understand how a sphere works? If you're in one spot and you go out and you're 7,000
Yeah.
foot, 9,000 foot below, if you draw a line straight down and come straight across, you're
I
not
understand.
going to do that on a ball because you're
I
behind a curve.
I understand you've got a carpenter's tool, right? It's like a 90-degree
Yes,
angle,
and
right?
that video proved you know nothing.
Yeah. So you've got you've got a carpenter's tool, right?
You find the total width of the area, divide it by 2, you get the angle, and you can find the height. I sat here and done the math on that video, which you made sure not to come to or kept quiet on. The math come out to roughly 29 to 30,000 foot. We have videos of planes flying above the clouds, therefore confirming that my geometry experience.
No, because you're not doing it correct. What I'm trying to say,
theories out.
There's no point if you're not.
But you're going to tell me I'm wrong.
Yeah, because there's no point if you're not going to let me explain.
You sat here and explained, and I've showed you said it didn't.
Yeah, and now I'm trying to explain in the.
Hold on a minute. You said.
Yeah, okay, carry on.
My curvature math. I sit there and done it twice and showed you. Yes, I did.
You're doing it wrong.
You paying attention, or you're blatantly lying. No, I done the.
Yes, you are, which is what I'm trying to explain.
Ma'am, I've done the curvature. I'll do it again. Since you're being so stubborn, calculator, 120 miles. 120
What calculator are you
times
using?
120 times 8 equals 115,200.
No, incorrect. That's
Yes,
drop.
that's a curve. Do you understand?
Drop is not curve. This is what I'm trying to explain to you.
Okay, look. We're looking at the side of the globe. We're looking at the side of the
Okay,
globe.
yeah, that's perfect. That's perfect. Yeah.
Now look, wait a minute. I'm fixing to prove you wrong. You're going to start battling. If we're here, 120 miles away is here, you're going around a curve.
Yeah.
I don't care what you call it. It's a drop. Yeah.
No.
Okay,
that's where you're wrong.
Yeah. Yes. No, look, if you're standing here on the top of the toilet paper roll and you want to get down here, what you got to do? Does it roll? No, you got to go down. And what shape is it? It's a curve.
No, you're wrong. Can I explain now?
You're going to explain how round works?
Yeah. Hold that up, yeah? Yeah, hold that up. Hold that up in front of the camera.
No, I ain't your puppet. You need to get your own props.
I'm trying to.
Prop.
Okay, don't use it. Don't use it then. The point is, if you was to hold that up in front of the camera and then you used a 90-degree angle to that, so like a carpenter's tool, and you used a 90-degree, and you used a 90-degree angle to that. So you had the carpenter's tool going off it kind of thing as a tangent and then a drop. The drop from that, so you're going across horizontal and then a down, right? Like a 90-degree angle. That drop is not curve. That drop is drop. That's drop from horizontal. It's not the same as curvature. It's drop.
Oh my God! Are you being that ignorant?
No, you are.
What shape is a sphere?
It's a ball. It's a sphere. It's 360 degrees.
What shape is a sphere?
A ball, a circle.
Okay, if you're on top of a circle and you walk to the bottom of a circle, what have you just went around? A half a circle. And you're saying drop is not a circle.
Because the drop is not curve. You're mixing drop and curve.
No.
Drop is different to curve.
Is that?
Okay, so if you imagine, if you have, hold on, if you have that.
I'm glad. I told you in them comments. You're showing.
Yeah, and I tried to tell you and explain to you.
And you just sat here and explained what a circle is, and then I said you're on top of a circle and you walk to the bottom of a circle. What did you just do? Go around half a curve, and you say a sphere is not curved.
Drop is not curved. No, I said drop is not curved.
No, you said a sphere is not curved.
Okay, have you watched?
You said a sphere is a circle.
A ball, a sphere, a curve.
You walked around to the bottom of a sphere. What did you just do? You walked.
I went 180 degrees. I went around. Yeah.
Thank you. You're proud.
But the thing. No, because the thing is, you're not understanding. There's a difference between drop and curve. So if you take that, if you take that toilet roll and you had a straight line going horizontal across, there's no point laughing. What's the point in talking to you if you're not going to listen?
What's the point of even asking you a question when you're going to deflect and not even admit you're wrong?
Because drop is not curve.
Yes, a ball curves.
Yes, a ball curves, but drop is not curve. 8 inches per mile squared is drop. Drop and curve are two different things.
That's right. A curve.
Exactly.
Now, you admitted a sphere curves. Now, if you on the top of the sphere and you walk 90 degrees, you walked around an arc. And what is an arc? A partial curve. Right?
90 degrees is not an arc.
I said, if you walk around, if you have that one point, if you're doing what you say and you want to make the center of the earth your point, you got to walk around 90 degrees. Make that straight line. Let's use geometry, lady. Now, once you get to that straight line, if you take a straight line from here to where you was, there is a curve right here. Here's where I was. Here's where I went. But yet, there's a curve in between.
No. See, you're not understanding. See, you're not understanding because you.
I just sat here and explained to you. If you walk around a circle, you want to use your degrees. here's 90 degrees. Here's where I was. Here's where I'm going. But yet there's a curve. Now, yes, it curves around. If you want to call it a drop, you can. It curves down. We can start here and go up here. It curves up. So that is a rise. If we're here,
The thing is,
no, I'm proving you wrong with geometry.
no, you're not. You're not, because you're not understanding.
Yes, I understand you. You want to talk about.
No, you don't.
Yes, I'm proving
No.
you wrong. Said,
Okay.
Said,
Can I ask you one question?
Now, go ahead.
Do you know what force the line is?
What?
Have you heard of the flat Earth experiment? What they want to do called force the line.
Tell me about it.
Okay. Well, there's this thing called force.
Oh. You do not understand sarcasm. Now, let's get back to what you were explaining that you're trying to deflect from now.
No, it's no deflection. This is how they use 8 inches per mile squared.
Okay, now, you talked about degrees. I'm bringing up your degrees. Now you're wanting to flip the subject. Let's talk about degrees. We're down here. We want to go up here. Now, if we made that, yes, we draw a straight line, we're going to have a gap right here. We're going to have a gap up here. Now, if we draw a straight line from point to point from where our feet was, that means this curve has just been cut off. You're trying to make it a stop sign, Earth. Don't you tell me about geometry. Now, I'm going to open you back up, let you deflect and say some more stuff, but we're over. I'm going to let you bury yourself some more. You may need to go get a job at building houses before you speak. Speak.
Okay, so like I was trying to say, force the line, if you was to force the line, if you know what force the line is how they would use 8 inches per mile squared. Other than that, unless you're using chord length as the distance, you are not using 8 inches per mile squared. So any observation you do and you try and apply 8 inches per mile squared to that will not work.
That, folks, is complete and utter deflection. Hey, thank you, Lord. My pride wasn't in this one, but that is total deflection. You let them speak, you show them they was wrong, and then they go to something else. Total deflection. I'm glad y'all got to see your little shield lady get roasted. Enjoy.